Hello friends, this is Durga again from IT University. At this time, as part of CCA Spark and Hadoop developer, I'm talking about calculating aggregate statistics such as average or sum using Spark in Scala as programming language. Already I have covered how we can actually do total sum, total average, get the maximum from the existing dataset by applying transformations such as map, and then aggregate transformations such as count, reduce, etc. In this video, and then I have also covered by key aggregations by using group by key, combine by key, reduce by key, and aggregate by key. We have just seen the introduction and the syntax and semantics of the and also the differences between all the four by key aggregations. In this video, I will be covering a business requirement in which we need to develop a Scala-based Spark application, which we will determine. First, we will design and determine which functions should be used, and then we will start implementing it. So the requirement is we want to get average revenue per day. So per day requires order date, and to get the average revenue, we need to have for each order we need to generate the revenue. And if you look at the actual tables in MySQL, I'm opening another terminal. So the VM comes with MySQL database with retail_db as the user, and password is Cloudera. So I typed Cloudera and I logged into the database server. Now I am switching to database called retail_db, and if you say show tables, it will list the tables, and all the information is available. All the information that is available for our requirement, which is to generate average revenue per day, is available in orders and order items. So if you actually describe on orders, you have order ID, order date, order customer ID, and order status. So we need order date from here because we want to compute average revenue per day. And then if you look at order items, there is a order item ID, order ID, product ID, quantity, subtotal, product price, etc. And we want to compute average. For that, we need to use subtotal. And also, order items is a child table for orders. Orders is the primary parent table, and order items is the child table. So any order customers place, there will be order ID generated, and that will be stored in orders table. But an order can have multiple items, and that each item goes to order items table, and there can be multiple entries for a given order in order items, and each order items have subtotal. So to get the average revenue per day, we have to add this subtotal on daily basis, and also we need to get all the distinct orders on daily basis, and then we have to divide the order revenue that is generated using order item subtotal by the number of distinct orders for the day, which will give the average revenue per day. So let's do the count on orders. So there are 68,883 orders, and there are 172,198 order items. So on average, there are 3 order items for each order. But not all orders make 2 order items. Sometimes you start the order and then you cancel it without placing any items into it, and those will not be available in order items. So for that reason, means you can validate that by saying select count of distinct order item, order ID, that is the column which represents order ID in order item table from order items. and you can see there are only 57,431 orders in order items, whereas in orders there are 68,883. It could be because cancelled orders might not made into order items, or some other orders might not made into order items. So we have to compute revenue for each day, and also we need to get distinct orders from the order item to generate the revenue, but order date is available in orders, so we need to join these two tables to get all the fields, and then we have to determine which aggregation should we use to perform, which aggregate function should we use to perform the required aggregation, and then we have to compute average. So let's start developing it. So this actually includes joining and aggregation. So this is means already I have covered how data is joined as part of the earlier videos, so I will not get into too many details about join itself, but we will use both joins as well as the aggregation concept to accomplish this. So first we need to read the orders and order items table, and the code is already in GitHub, so you can just copy paste these two things. So once you have orders RDD and order items RDD, in orders we have seen that order ID is the order date is the second field. We need order date from the orders table, and order, but to join these two we need order ID. Initially I will not pass out, I will pass out order date from orders tables as value, and order ID will be the key, and then we will join the order items dataset, in which we will be passing order item order ID as key, and the subtotal as value. Okay. So first we need to apply map function to create key value tuples of the required fields, and that we can do by using val orders map RDD equal to, I will just name it as orders map equal to orders RDD dot map function. Rec is the parameter name, and I want to create tuple of two items. The first one is order ID, which is represented by 0 in our dataset in HDFS, because data is delimited by comma in HDFS, so we have to apply this function. This will get us order ID, and then I want order date also. Split 1 and hit enter. Before hitting enter, order ID is integer type in the database, so it's better to apply toInt function, both for the performance reasons and also in some cases where you want to sort, if you have to sort as integer, it's better to do the transformation as early as possible. Here it might not be that relevant, but it's always highly recommended to convert the data types as early as possible. In this case, I am converting order ID to int here and hit enter. Now you can say orders map dot take of 5 dot for each println and hit enter. You can see that you have order ID as the first value in the tuple and date as the second value in the tuple. Now we have to get order items map, and we have to order items RDD dot map, and then rec is the parameter name, and I want to generate tuple which pulls order item order ID, which is the second column in the table. Here you can see this is the field which you are trying to pull after splitting by the delimiters. And then I want to convert it into toInt, and then I want to get the revenue also. So revenue is the fifth field. which is represented by order item subtotal for each order item. So we need to get this, and here I have to convert into float. And hit enter. So this is the function which we have used, and now you can actually say order items map dot take of 5 for each println and hit enter. Now you can see that for each order ID we are getting the revenue here. Now we can join these two data sets and it will generate order ID as the key, and whatever we fetch from orders and order items as values. So orders join equal to orders map join order items map and hit enter. I have to specify it as val here. Now orders join have the join data set. You can validate by saying orders join dot take of 5 dot for each println and hit enter. And you can see that the first element in the tuple is order ID, and the second element in the tuple is the tuple itself, in which the first element is the date and second element is the revenue. Now what we have to do is we have to use this data set, generate the so we need to get two things. One is sum of the revenue on daily basis, and second one is getting the distinct orders. So here by moving the order date into the key, so right now in these tuples the key is order ID and value is this one, okay, but we want the revenue, we don't need order IDs as part of our final result, so we can discard order ID. But before discarding the order ID, we have to get the revenue per order. Once you get revenue per order from this data set, you can actually add revenue per order on daily basis and number of orders on daily basis, and then you will have the required output per key, which is day. You will get the revenue per day and the number of orders, and you can divide those two. So let's see how we can do this. Now you can say orders join map equal to orders join dot map. In this case I have to use map function. Our input record is of tuple in which first element is order ID and second element is tuple. Now I have to generate a key of tuple and then value. The value will be revenue, and this bracket is to close the bracket of map function. So as part of the first value in the tuple, it's a tuple, so it requires two values. First one is order date, so order date is so this is represented by rec dot underscore 1. You have to use underscore notation to read the tuples. So the first element is represented by underscore 1 and the second element is represented by underscore 2. Okay, so here we need to have key because key as a tuple, because we want to compute revenue per order. On each day, orders are unique. Once an order is placed on a particular day, it will be only for that day. It will not be spread across days. So you can move order date to the key, and you can actually compute the revenue by key, which will generate revenue per order per day. Okay, so in this case the key will be rec dot underscore 2, because we want to get the date as the leading column in the key. And of the second tuple, the first column is date. So we have to use rec dot underscore 2 dot underscore 1, which will be the first element in the key, or first element of the first tuple, which will be emitted out of this map function. And then I want to have order ID also as part of the key, which is represented by underscore 1. So now the key will be this one, comma this one. The tuple will be the key. The tuple of both the elements will be the key. And now here I want to have rec dot underscore 2 dot underscore 2, which is nothing but order item subtotal for each order as the value, and hit enter. I have to define it as val and hit enter. Okay, now you can actually say orders join map dot take of 5 dot for each println, and you can see that the key is nothing but date comma order ID, and you can see this order ID which is repeated 4 times, and we have to add all these things to get the revenue per order. Once you have revenue per order, you can just add revenue per order to get the cumulative revenue for that day, and also you can add all those unique order IDs for that day to get the number of orders for that day. Okay, now we have to discard the order ID. Order ID is not required anymore. For that, you have to orders order item subtotal per order equal to order order item subtotal per order. That is the name I have given. You can give whatever name you want. Orders join, what is this name? Orders join map dot, again I have to write a map function in which I can discard, 1 minute, sorry, first I have to add the revenue so that I get revenue per order. So let me do this. Val revenue per order equal to orders join map dot, I have to use reduceByKey here because I have to add all these. So in this case, if you see the 57,436 order, you can see there are 4 entries, and there could be more also. We have to add all those things and get revenue for each order for each day. Okay, for that now we have to determine which aggregate function should we use. In this case, the input type is the float and the output type is also float. Okay, because we are passing revenue as the value for the aggregate function, and the output is nothing but the aggregated revenue. So there is no change in the data type. So either you can use reduceByKey or combine_by_key. You don't need to go with aggregateByKey, and you should not use groupByKey because groupByKey, even though it can do aggregation, it is not as efficient as it does not use combiner internally. So in this case, either we have to use reduceByKey or combine_by_key, and combine_by_key can be used when you want to provide custom functionality for combiner. In this case, we don't need custom functionality. The addition of revenues are additive, so we can so if the combiner picks these 2 revenues in one iteration and these 2 revenues in another iteration, then it will compute intermediate values such as $360 for these 2, and then approximately $800 for these 2, and reduceByKey can apply the same logic to add these two things and give the final revenue for that order ID. So the combiner logic and the reducer logic can be will be same. So we don't need to use combine_by_key. Instead, we should use reduceByKey, which is very simple to implement, and it takes accumulator and value as the parameter, the tuple of accumulator and value as the parameter, and you can add value to the accumulator. It's a tail recursive function, and now you can hit enter, and you can validate the results. Revenue per order dot take off 5, or let me take off 100 dot for each println and hit enter. Now you can see that order IDs does not repeat, and it is actually giving the sum of the revenue for each order. Now we can discard this one. So we and then we can actually add revenues for each day, and also we need to get the number of records for each day to compute the average. So to discard, we need to apply map function. So our parameter name in this case is revenue per order. Let me say revenue per order map. This is the new variable name, equal to here revenue per order dot map, and I want to pass each record as a parameter, and here I want to discard the order ID. So the first tuple is a composite tuple. The first tuple itself is the first value in the tuple itself is a tuple. So I want to get the first element of the first tuple as key, which can be represented by _1 dot _1, and we can discard the order ID, which is the second element of the first tuple, and the value will be rec dot underscore 2, which is this one, second element of each of the tuple, and then close the brackets and hit enter. Now you can actually say revenue per order map dot take off 100 dot for each println and hit enter. You can see it is now the tuple of orders date, and there can be multiple entries for each day. For example, if I do sort by key, you can see that there are multiple entries for each day. Now we have to add these revenues to get the total revenue for each day, and also we need to count these entries, which will give the count of distinct orders, because each element is a unique order, and then we can divide to get the average. So for that, now again we have to think about all the 4 or 5 aggregate functions we have: group by key, reduce by key, combine by key, and aggregate by key, 4 of them, and we need to determine which one should we use. We cannot use group by key because it does not use combiner. We cannot use reduce by key because in this case the input is revenue for each day, for each order, and it is of type float, but the output has to be revenue and the count. It's not just revenue. So output is a tuple of float and int. As the data types are not matching, we can neither use reduce by key nor use combine by key. Instead, we have to use aggregate by key. And now you can get revenue ag per day equal to, it is val, let me name it as revenue per day, sorry, the name of the previous RDD is revenue per day map dot, here I have to use aggregate by key, and it takes 2 parameters in 2 separate brackets, and the first parameter is that we have to initialize the tuple because the output is a tuple, so we have to initialize it as a tuple, and the first one, if it is revenue, it is of type float. So the first element has to be initialized to a float type, which can be represented by 0.0, and the second element is of type int, which will be count, and it is represented by, it is initialized by 0. And then it takes two parameters, okay, comma, two parameters, and each parameter is nothing but a closure function or anonymized function. So we have to implement the functionality also, okay. And here it is, let's name it as accumulator and revenue or value. So here also accumulator and value. So by the time it goes to the so this is the functionality for combiner, and here you have to define the functionality for the reducer, and by the time it goes to the reducer, the outcome is tuple. So you have to implement tuple logic here. You have to add both the elements in tuple as part of the reduce function. So here you can say accumulator dot underscore 1. So the first elements will be the intermediate values of the revenue. So you have to say accumulator dot underscore 1 plus value dot underscore 1. This is the one element in the return value of the reduce function, and the second element is also the same thing, accumulator dot underscore 2 plus value dot underscore 2. So the output of the reduce function will be the tuple, which will have the revenue, which can be written by this, and the number of unique orders, which can be written by this. And then as part of the first one also, it has to, so the output of the combiner, this is now we are implementing the combiner logic. The output of the combiner will be input to the reducer, and it has to pass tuple only to the reducer. The data type between the combiner and reducer cannot change, so you have to generate tuple here. But your value, which is passed from the map, is just a float value. So here the value is only float. It has only one element. It does not have two elements. But your accumulator, you have to build a tuple so that you can pass tuples to the reducer. So here you have to say accumulator dot underscore 1 plus value. Okay. So all the revenue will be added to the first accumulator, and then first element of the accumulator, and then you have to add 1 for each order for the second value of the accumulator. So accumulator is the tuple here. For the first one, we are adding the revenue, which is piped from the map function, and the second element we are just adding once because all the orders are unique for a given day. So by just adding them, we will get the distinct count of orders. Like this, we can implement the combiner logic. Now, if you observe, the combiner logic is different. It has accumulator dot underscore 1 plus value at the first to get the result for the first element in the tuple, and the second element in the tuple is just added with 1, whereas your reducer logic is just adding the tuples, each element of the tuples. So the logic is different in these cases. So as the logic is different, and also the input type and output type are different, because the input type is just of float, and the output type is of type output is of type tuple with first element being float and the second element being of type integer, and you can hit enter. Okay, it is revenue per order map, not revenue per day map. So that's why it is failing. I have to say revenue per order map. and hit enter. Now it is successful, and now I can say revenue ag per day dot take of 100 dot for each println and hit enter. Now you can see it is generating the revenue for each day, and the total number of orders for each day, total number of unique orders for each day. You can also say count to get the number of records. There are 364 because we have 364 days worth of data, hence the results seems to be fruitful. But if you look at the results, now you got the revenue and the distinct count of orders. You have to divide these two values to get the final average. For that, you have to apply map function again on this, and the record will be again of type the record will be of type tuple, for which date is the key and a tuple is the value, or date is the first attribute in the tuple and another tuple is second attribute in the tuple, which have revenue and the distinct number of records. So we have to get the date from here, which is represented by rec._1, and then I have to divide the first element in the second the first element. So this tuple have a nested tuple, so the first element of the nested tuple has to be divided by the second element of the nested tuple. The first element of the nested tuple can be represented by rec._2. Rec._2 is this one, and ._1 is this one. So tuples are used are pulled using underscore notation, and then I have to divide with rec._2, which is nothing but distinct number of orders for a given day. And then I can close this, and then I can actually say collect dot for each println and hit enter. Now you can see that you got the order date and the average revenue for each day, and you can actually do sort by key dot collect, and you can see for July 24th it's $588.34. You can apply round function if you want. So this is how you can actually develop aggregations for a given requirement. All the code is available in GitHub. Whatever I have shown here, it is implemented exact same way. So you can go through this and make sure that you run the command println after each step, so that it is clear to you how the data is represented internally. Unless you understand how the data is represented internally, you will not be able to write the code effectively. That is very, very important. So for each and every step, make sure it is working as expected, and the tuples and the lists, whatever is applicable for your requirement, is generated as expected, and then only you will be able to write code which can be executed without any issues. Okay. That being said, you can also validate the revenue. Means you should validate your results once it is done. You can go to MySQL database if you have access to one, and then you can write a query here, which we will see as part of the next video. I will also show you how you can actually run SQL also to get this. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide feedback, please use the comment section of the video. If you have any technical questions, please raise the questions in Stack Overflow with appropriate tags. I'll be closely monitoring those, and I will be I will try to respond to you to the best of my knowledge, and also others can also respond to your questions. So I will not become bottleneck if you ask questions in Stack Overflow. On top of that, if you want to discuss further on certifications or Apache Spark itself, please do join my LinkedIn groups, ITversity, Apache Spark, ITversity Hadoop certifications. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.